Alright, so we are going to talk about ion formation now, which just sounds just so boring when you say it like that, doesn't it? Um, it's really not that bad though. It's actually really simple. So basically, things form ions to fill their octets. Now remember we talked about valence electrons, and I told you we would talk about the octet rule. So the octet rule basically states that all atoms want to have 8 electrons in their valence shell. Now that means basically just all atoms, they want to have 8 electrons in their outermost energy level. All right, that's what they want. That's the deal. That's their goal, and they're going to do everything they can to make that happen. The way they do this most is by, well, they form compounds, and they also form ions. So the way it'll work, like quick review. So remember, valence electron, so it's like we've got, this is like 1 valence electron, 2, then this whole middle thing is 2, and then you have like 3, 4, 5, 6, 7, 8, right? So the way things form ions is basically this. They will do it in such a way that whatever is easiest for them to form the ions, they will. That means that, like, so let's look at something like sodium. Sodium, sorry about that. Okay, I had to pause it for a minute. So sodium has 1 valence electron. Now, the way it's going to work, sodium can either, it's going to adjust as necessary so it can have 8. It has 2 options to get 8 electrons. It can lose this single electron, and if sodium loses an electron, it will go and become like neon. All right, it will become like neon. Now, that's actually kind of cool in terms of being like neon, because then all of a sudden, you know, it has 8 valence electrons. Because if you take away 1 electron from it, it goes and has the configuration of neon. It doesn't become neon, it just becomes like neon. Or sodium can gain 7 electrons, and it'll go from 1 valence, it'll become like argon. So those are the 2 choices that sodium has. Now, sodium is lazy. All atoms are lazy. They're going to do the thing that requires the path of least resistance. So what sodium will do, it's going to get rid of this electron. It's going to give it away. It's going to form, it'll, you know, in compound formation, it'll give it away, and sodium will become a positive ion. So it'll become like neon. It'll become a positive ion. Now, that translates simpler to pretty much everything in this first column. They all have 1 valence electron. They all form positive 1 ions. Now that's something I would write down permanently on your periodic table. Make a note somewhere. This entire column, positive 1. All right. You want to look a little further? Let's look at magnesium, which is, you know, this has 2 valence electrons. Now what's magnesium going to do? It can lose 2 to get back to 8, or it can gain 6. What's easier? No, it's going to lose 2. So it's going to get rid of both of these, and it'll form a positive 2 ion. So this whole column, positive 2. Again, I would write that down. Very important. Now this middle, the transition elements, this whole middle, that's a little bit more, just, you know, it's a little murky. These things form all kinds of goofy ions. We'll talk about those another day. But then you move over here, you've got your third column. So again, the choices are lose 3, gain 5. They're going to lose 3. That makes this column plus 3. Though as you get further down, there are some exceptions down in these bottom rows, but we'll talk about that later. Now this middle column, you're going to think it's like plus or minus 4. Well, we'll talk about that in a minute. Let's go to fluorine instead. So now let's look at fluorine. Fluorine has 1, 2, 3, 4, 5, 6, 7 valence electrons. So fluorine has the choice of losing 7 or just gaining 1. What's easier? Gain 1 electron, right? So it's going to gain 1, so it's going to get an extra 1, and that'll make it a -1 charge. And that makes this entire column -1. So this will gain 1. That will appear. So these are going to lose. This will lose 2. This will lose 1. I'm just filling this out so that you can do your worksheet later. So that's going to gain 1. So that makes this entire column here a -1 charge. So oxygen and all the elements there, it's, you know, it can gain 2, lose 6. It's just going to gain 2. All right, had to pause again. Interruption. And then so oxygen, it's going to lose 2, or pardon me, it's going to gain 2 to become a -2 charge. So it's going to gain 2 electrons. All right. And then nitrogen, same deal. It's going to gain 3 because it can gain 3, lose 5. It'll gain 3. It's always the lesser amount. So again, you should be writing these down. Like, these are important. You need to know these. All right. And then last but not least, and I apologize if the periodic table looks so basically blurry on here. I don't know why. I'm going to figure that out. And then last but not least, this middle column, you're going to think it's like plus or minus 4. It's like carbon and silicon, they don't form ions. So I don't really give an ionic charge here. Tin and lead, they can be +2 or +4. They're kind of weird. Germanium is +2-ish, +4-ish. Like these don't really form ions, but then tin and lead can be +2 or +4. So in short, I just simply say kind of wait on the middle column. It doesn't really do ions, at least these top 2. And then these bottom 2 we'll get to when we get to transition metals. Now the noble gases, notice we didn't talk about them. They don't form ions. Why? Because they have 8 valence electrons. They're totally content and happy. They don't need to form an ion. So they're good. They don't form ions. So that should help you with the basics here in terms of figuring this out, what forms an ion, what doesn't. And there you go.